joining us this morning to attend these talks. My name is Caleigh O'Connor, and I'll be speaking briefly about the MT Explorer's versatility and portability through the lens of example spectra. Some are artifacts of years past captured by Vladimir Doroshenko, while others are advances we made just in this past year. Okay. Obviously, portability is one of the most important aspects of our MT30 and what makes her so special. At just under a cubic foot, in size and around 37 pounds, it is perfectly suited for even me to take on the go. I asked Eugene, I don't know where he is, to model for this picture to make it look extra small, but he said no. So, and of course we offer a battery pack for field analysis, as well as an electrical backup in case of power outages. It's compatible with a wide variety of, oh my god, I keep doing that. Compatible with a wide variety of ion sources. The major ones are listed here. This year we focused especially on honing our electrospray analysis, which has been really exciting. And you'll likely notice this as we go through all of the ESI spectra I have for you. So, for some context, I interned at MassTech for the past 2 summers, and now work full-time. I first heard about the MT30 through my dad, who's a lawyer, who likely got his information from our company's owner, Richard, who's a finance guy. And so, hopefully this is the first time from Enrico that you've heard about the MT30. So you can compare the impressions that you may have and that I got. My dad explained it as a device that can be dropped from a helicopter onto a battlefield, which will shoot a laser into the air to detect if there are any toxins or chemicals there. Not quite, but there are some kernels of truth. As we saw, our instrument is quite portable and suited to field analysis, and hopefully in the next rendition we can add a parachute. The MT30 is well suited for analysis of ambient conditions and certain chemical warfare and battlefield compounds of interest. On the left, we have spectra of methyl salicylate, which is a mustard gas stimulant, and that was analyzed with Secret GC SPME. And below is our own APCI source. And on the right, we have the same data for RDX, which is Rural Demolition Explosive Recyclinite. This perfectly ties into our next application, which is ambient conditions monitoring. Next week, a few MassTech representatives will be taking the MT30 to the battlefield, aka a West Point Military Academy STEM summer camp for 9th and 10th graders. And there they will have the opportunity for hands-on mass spec experience. Their activity will be to take a swab of an unknown essential oil and wave it in the proximity of our APCI source, like so. And they'll obtain a spectrum and compare to major peaks in a glossary we made, and they'll determine which essential oils they have. So on the left is our APCI spectrum of eucalyptus essential oil and our proposed molecule assignments, and then on the right is sweet orange essential oil. Okay. Surprisingly, this is my first ASMS, and I'm sure many of you can relate that I was burnt out even before I boarded the plane to get here. But there is an energy here that I'm hesitant to attribute to breakfast seminar coffee. Luckily, we have made significant advances in drug detection this year with the MT30. So next year when the conference is at our home turf in Baltimore, feel free to stop by the lab for some free harm reduction services. On the left, you can see an you can laugh. On the left, you can see an ESI MSMS spectrum of 100 nanograms per milliliter of cocaine spiked in synthetic urine and extracted via biospemy. And on the right, you can see an ESI MSMS of 10 nanograms per milliliter of fentanyl reference standard. We are expanding our analytical frontiers to encompass materials manufacturing applications as well. Here are the ESI MS and MSMS of 4,4-difluorobenzophenone, a polyether ether ketone polymer precursor. Say that 10 times fast. I believe we use peak for our ESI and APCI module composition, so relevant to us as well. Of course, any company that wants to make money has to have some pharmaceutical applications. So that is another aspect we focused on this year. On the top left, we have an ESI MS spectrum of what we propose to be the ammonium acetate adduct of sucralose, which is a common pharmaceutical excipient. And on the bottom left, we have the ESI spectrum of the flavonoid, procyanidin. Flavonoids have been pharmaceutical intrigue lately due to their antioxidant, antimicrobial, and even anti-cancer properties. And on the right, we have an ESI full scan of a 7-nitrosamine mix, and 5 of which we can detect with very limited method optimization. Nitrosamines are of particular interest to the pharmaceutical community as they are being detected in drug manufacturing processes, which is a problem because they are extremely carcinogenic. I will wrap up with one of the more exciting developments in our ESI highlight reel, which is the successful, if a bit unrefined, acquisition of spectra from peptide mixes. The spectrum here is from a Waters NIST MAB tryptic digestion standard, and on the right highlighted are the peptide fragments that we were able to visualize in the spectrum. We captured about 66% of the light chain and about 42% of the heavy chain. This is particularly exciting to me as my background is in microbiology. Finally, there are two representative ranges from an ESI-MS of the Waters mass peptide mix. The left shows a lower mass range of about 200 to 400 Daltons, while the right shows a higher mass range of 800 to 1,000 Daltons. And the shaded cells here are the peptides that were visualized by the analysis. So that is all I have for you today.
Thanks for a very, very quick run through. Are there any questions for Caleigh?
So what is the standard of this MT30? Standard and Versatility?
Yeah, we have 3 different models, I guess. Some go to 1250, and then I think 1700, and then 2000.
Any more questions for Caleigh? Thank Caleigh again.